introduction today, like yesterday?
Yeah, sure. We will make a quick introduction. Yeah. So, good afternoon and evening to everybody to Test Asia Hackathon. So, welcome back to the Test Asia Hackathon 2022. And Mr. Crow is back here to actually teach us on part two on building a dapp on Tezos in LIGO. Yeah.
Okay. Hello, everyone. So for those of you who are not here yesterday, so my name is Claude. I work as developer relations for ECAD Labs, so a company mostly known in the Tezos ecosystem for creating and maintaining Taquito. But today I'm going to talk about LIGO. I've been writing smart contracts in LIGO for 2 years and a half now, and it's a language that I really enjoy using for smart contracts. So today we're going to talk about writing tests in LIGO. So it's a feature that's been introduced in LIGO, I think this year, maybe like 6 months ago or something like that. So it's still pretty new, and a lot of people don't know that it's possible to write tests using the same language that you use for smart contracts. So today I'm going to show you how to do that. So you need to know a little bit of LIGO to follow today. So if you followed the presentation yesterday, then you know everything you need to know to follow today. Otherwise, if you have already checked the documentation or already wrote some contracts in LIGO, then you will be able to follow today. We're going to write some LIGO code for the tests. The first thing that you need to know about the test framework is that it uses the same language, so the same syntax, the same language. You can use LIGO to write the tests. For your contract. Before it was available, if you wanted to test your contract, what you would have to do is originate the contract maybe on a local node, Flex Test House, or on a test net, and then write tests in JavaScript using maybe Jest or Mocha. And so it needed a lot of setup. Now you can just write your test in a second file in your project using LIGO. And one of the things that I like the most about writing tests in LIGO, well, actually there are two things. The first one is that you are able to use LIGO as a normal language. You're going to use LIGO outside of the context of a contract. So you're still going to test the contract, of course, but there are also some things that you're going to do that feel a little bit more like using a regular programming language. So that's very fascinating because you spend a lot of time, learning LIGO and using it and getting some experience. And now you can also use it as a normal language to write your test. So it's pretty interesting. And also so today we're just going to write some tests for demonstration, but I've been testing some bigger projects using the test framework, and I was able to run hundreds of tests in a matter of 1 or 2 seconds. So it's really fast, so that's why it's a very good idea to write your test directly in LIGO. It's going to be very fast, and I compared the test on LIGO with Jest, and where Jest can take up to 10 seconds, the tests in LIGO are just going to take like a second. So it's very fast, and it's a new experience of using the LIGO language. Okay, so I'm going to share my screen, and we're going to write the tests, and I'm going to explain to you at the same time how it works. You will see that it's pretty similar to using the language when you write contracts. The syntax is obviously the same. There are different modules that you use. There are also different types of value that you're going to use for the test, and we're going to see all of that while writing the test for the contract that we created yesterday. So just a second to share my screen. Okay. Okay, so this one is the contract that we wrote yesterday. So we're going to create a new file. So this one is more of a personal convention. I'm not really sure how other developers write a name for their contract for their test, but in general I call it .test.mligo. So remember, you still have to use that mligo extension to tell the compiler that you're going to use the camel ligo syntax. So here, before starting the writing tests, there are two things that we're going to do. We are going to include the contract that we want to test, and then we're going to do some setup. So to include the contract, you can just include it like that, and then you put. So that's going to be this contract that we wrote yesterday. And then the test have to be inside a variable that's called test, like that. So you remember in LIGO, you can create like a mini scope and get the result of the execution of this mini scope inside a variable. So that's what we're going to do here. We have a test variable, and that's the one that's going to be evaluated at the end to check. So the compiler is going to take that variable and check that the tests run properly. There's also this variable has to return a value of type unit. So in general, when you don't have a lot of tests to write, you will see that there's an assert function that you can use that returns a unit. The problem is that if you want to add another assert function after that, then this one you will have to change it to make sure that it doesn't return before the end of the test. So in general, what I do, I just put a unit like that at the end, and then I don't have to worry about the value that's going to be returned, because I'm sure that it's going to be this one, this unit. And then now we can set up the environment to run the test. So when the test is going to be compiled and evaluated, the LIGO compiler is going to provide a certain environment for the tests. What you need to know about this environment first is that you're going to be provided with a couple of accounts to run tests. The thing is that the first account that's going to be created is also going to be the baker. So in general, and as we're going to see here in the test, there are some tests where you want to check if the balance of a user changed after a transaction to see if the transaction was successful. And if you use the account for the baker, it's going to give you a result that's probably not expected. So in general, I like not using the first account for tests, so the compiler can use it for baking, and then I use the second, and I create a third account, and I use those two accounts for the test. And the way to do that is pretty easy. So just like when you write contracts, one of the modules that you're going to use a lot is the Tezos module. When you write tests, there's a test module that you're going to use a lot. There are a lot of methods available in that module that you're going to use to run your tests and to do different checks and different operations in your test. So first, we're going to say that we want to reset the state, and we're going to create four accounts like that. So that's how you reset the state of the environment. And now we can assign our account. So we will have a player one. So that's, once again, we use the test module, which has and bootstrap account. So this one is going to create an account, and so the first account is going to be 0. So that's going to be the baker's account. So we want to use the second account. So it's going to be the number 1. And so here it should be player 1, and then here player 2. And we write the same thing, bootstrap count 2. Okay, so for this test, we are only going to use 2 players. So it's going to be easier to write tests, and it's going to be also easier to reach the end of the game, so we can test it faster. And it's going to work exactly the same if you have 2 or more players. And after that, there's another method on the test module. It's called set source. So set source is going to set the source of the transaction. So we're going to tell the compiler that, okay, this account is going to be the one that's sending the transaction, and that's the one that's going to appear as the source in the contract. And here it's going to be player 1. We're going to start with the player 1, and then when we want to use the player 2 to make tests, then we're just going to set the source again, but this time to player 2. We also, because we just want to have two players, we're going to set the tickets available and the max tickets to 2. So here I'm going to put it in a variable because later I want to test that I have the right number of tickets. So it's going to be easier to have it available like that. So now, in general, what the first thing that you're going to do when you test a contract is that you want to originate the contract. So of course there's no blockchain here, so it's emulated, but the test framework in LIGO uses the same thing like in the Tezos blockchain. So it's very reliable, and you know that if it works in your test in LIGO, you can know for sure that it's going to work on the Tezos blockchain. So here we're going to originate the contract, but first we want to create the initial storage for the contract. So because we're going to have to provide different values to originate the contract. So here for the initial storage, we start with the players. If you remember, the players was a map, an empty map of it was NAT and address. But we have ticket cost. So let's just set it to 1 Tez. The accounts that you bootstrap at the beginning, I don't remember exactly how many tests they have, but they have a lot. I think it's close to 1 million or something like that. So you don't have to worry about that. And the tickets available. So that's where we're going to use this tickets variable here, and then max tickets also going to be like that. Okay, so here we set the initial storage for the contract, so an empty map of players, the cost for the ticket, and then the number of tickets that are going to be available and the maximum numbers that we can have in the contract. Okay, so now it's where we're going to originate the contract. So the origination process of the contract is going to return different values. Only one that we really want, that we really need here is going to be the address of the contract. So it's going to return a tuple with 3 different values. But here the one that we really want is the address of the contract that we're going to use later. So we're going to keep it. And there are 2 other values here that we don't need, so we can just put an underscore instead. So the underscore means that I know there's a value here, but I don't need it, so you can. I'm going to ignore it. And once again, we use the test module, and there's originate from file. So there's a method called originate from file. that you can use, and then you can. So that's going to be the contract. And you have to put the name of the main function in the contract. So here it's not like the compiler by default. It's the function is called main. Here you have to write the name of the function in the contract. So if you remember, yeah, so we called it main here. So that's this one. So main. There's a list of string. So here it's going to be empty, and that list of string is going to be a list of the name of the views. So we have a view here, but we're not going to test it, so it's not really important. And okay, here we're going to put the storage, the initial storage that we want to use to originate the contract. So as I told you at the beginning, the test framework in LIGO is going to use also different, a few types that are not available when you write a contract, and they are just types that you use for testing. And one of those types is called Michelson program, and so it represents a value in Michelson, and you can easily get a value of that type if you use the compile value function method on the test module, and then you pass as an argument the value that you want to cast to a Michelson program. So here our storage, and then the initial balance of the contract. So here 0 Tez. Okay, so this here, and you see once again in Camel LIGO. So here we have a function, and here are the parameters of the function, and you see that there are no operands, no commas, nothing. You just put them one after the other. I put them like that in one on top of the other, just to make it clear. But of course, you can write everything on a single line. It's not a problem. You just put a space between them, and the compiler is going to figure it out. So here now we are supposed to have the contract available for testing. In general, what I like to do is to make like a very quick check, just to make sure that that it worked, and that the contract, the storage of the contract has the expected values. So that's what we're going to do. The first thing that we are going to have to do to interact with the contract is that we need a special type available in the test framework that's called typed address. And in order to get it, as you probably guessed, we're going to use the test module. So, sorry, lottery, or let's call it lottery typed address. So here you will have to explicitly type the value that you expect, the type of the value that you expect, and here it's going to be of type. So those types, as soon as you include the contract here, everything that you have inside the contract is going to be available here. So first you have to be careful not to, if you declare a new type in your test, you have to be careful not to use a type that's already declared here, or it's not going to work. But all the types that you have here are also going to be available in your test file. So here param and storage are going to be available here. So we're going to use them here. And here we return a typed address, and address, and then test, cast, address, and then we're going to use this. So this address comes from here. After we originate the contract, we're going to get the address of the contract, and then we turn it into a typed address. And you will see later how we're going to use that typed address. And well, actually, not later. We're going to use it right now. So I just want to check quickly that one of the properties of the storage has been set properly, just to make sure that the contract is available and the storage is correct. So here in test, we have another method called get storage. So that's the method that you're going to use to get the storage of the contract, and you just pass the typed address to it. So now we have the storage of the contract, and remember the storage is supposed to be this one. So we're just going to assert storage dot let's say max tickets. This one should be equal to 2n, like that. And then to run the test, on this tutorials, I want to focus on the syntax of LIGO, but you can check the documentation, and you can get the compiler through a Docker image. That's what I have installed here on my computer. And then you can run different commands to compile contracts or to test. And then here the command is going to be LIGO run test with the path to the test. Works. Oh, okay. So it says that I'm not using player 2 at the moment. So let's see. Okay. And now, so you see this message here, everything at the top level was executed, and the test executed with value unit. So that's this one here. And so if there's no error message, it means that everything is fine. So it means that this assertion is true, and that everything works. And so everything now is set up, and we can start writing tests. We know the contract is originated and the storage is correct, so we can start testing the behavior of the contract to make sure that the contract behaves in the way we expect. Okay, so now we're going to call the buy ticket entry point. So let's have a look at it. So you remember this entry point. We're going to make sure that player 1 can buy a ticket. So first, I'm going to write a test to make sure that it's not possible to buy a ticket if you don't send any amount with the transaction. So that's what we're going to do now. So we're going to create a value of type contract in order to interact with the contract. So here you will see the difference between the test framework and writing a contract. When you write a contract, that's the code so here it interacts with an implicit account, but the code to interact with the contract is pretty similar. So that's you do something like that, and here it's going to be a little bit different. You have a method to contract that you can use, and we're going to use the typed address here. So now we have the contract, and we can send a transaction to the contract and see if it's going to fail if we don't pass any amount with the transaction. So here we're going to match like that. Once again, we use the test module. So all the different methods of the test module are available in the documentation. So I would recommend you read the documentation so you can get familiar with all the methods that are available and everything you can test in LIGO. So here it's going to be transfer to contract. And now we're going to use this value. So here, the transfer to contract method takes 3 parameters. The contract, the parameter that you want to send to the contract. So here you remember the parameter is going to be one of these 2 branches of the variant. So here we want to test buy ticket. And so you remember here we have here we have a safeguard, that if we send an amount that's less than the ticket cost, then it's going to return invalid amount. So the contract is going to fail and return invalid amount. So that's what we're going to test here. So I put 0 Tez on purpose, just to make sure that the contract is going to fail. It's not possible to buy a ticket if you don't send any Tez. So that method, the transfer to contract, and there are also different methods in the test framework that behave the same, is going to return a variant with 2 branches. One of them is going to be called success, and the success, there's going to be a value associated with it. That's the gas that was used by the transaction. So here we don't need it. We just want to check if there's a success, and of course, if the transaction is successful, it means that there's a problem with the contract. The contract didn't behave the way we expected. So we're going to write assert false. So the test suite is going to fail, and you're going to get a message that the test didn't work. And then the second branch is called fail, and fail is going to return an error, and that error too is going to be a special type that you use when you test contracts, and that type is also a variant. And that variant, so we have to do pattern matching on that variant again, because we want to check that so here, if the variant goes in that branch fails, so we know that the transaction failed, and that's 50% good. The other 50% is to make sure that it fails for the right reason, and the right reason is going to be that error message invalid amount. So that's why that's what we want to test. So here, this error is going to have a type, a variant type with 3 branches, and the one that we want to test is called rejected. And rejected here returns a tuple, and here, or let's call it error message. So if you remember the syntax of LIGO, here every time there's a pattern matching like that, it's like a little scope by itself. So I can reuse the same variable names. So even here, if I write error like that, it's not the same one like this one, it's a different one. And so it's not going to overwrite the previous one. It's just in a different scope. But just for the sake of clarity, we're going to call it error message, rejected. And now we can check. So let's write the other cases. So I told you there are two other branches in that variant. The second one is balance too low. If there's a problem with the balance of the account sending the transaction, and the other one is called order. If there's another error that happened, but in any case, we don't really care about that. We just want to make sure that we hit the rejected branch. So here we can just assert false. And here, so we're going to test the message. So here, if error message. So here, error message is going to be of type Michelson program. So you have to compare it with another value of type Michelson program. So we can, like we did above, we can use that method, the compile value one, and then we pass invalid amount. Invalid. So that's the string that we expect to have when the contract fails. So if the error message is equal to that string, then it's good. But if we get another error message, then it means that there's a problem. It's not the message that we were expecting, and we can assert that it's false. And of course, here, let's not forget in. Okay, so here we wrote the test for the buy ticket entry point. So this transaction should fail, but of course the test suite is going to go through, because that's the expected result. So we can run it again. Okay, and you see that everything worked. So it means that we did get this this error message when the contract fails. So it means that the contract behaves in the way that we expect. So now let's send another another transaction to the contract, but with the right amount. So let's not rewrite everything. So here we have the storage. So we can just use the value in the storage just to make sure that we have the right one. And the value is this one. Well, actually, we can just hard code it. It's 1 Tez. Okay. And so here it's going to be a little bit different because now it's not supposed to fail. So if it fails, we're going to assert false. So we're going to have an error message. But if it works, then we're going to assert true. And if you notice, every time I rerun the test in LIGO, then the contract is going to be reoriginated, and you get a fresh contract with fresh values. So you don't, so you know exactly what kind of properties you're going to have in the storage. So now let's see if this if that's going to go through. Oops. Okay, so now this one failed and this one went through. Okay, so now we expect that we still have one ticket available. So that's where we're going to use player 2. I'm going to copy this one here. I'm going to switch the source of the transaction. So now it's not going to be player 1, but it's going to be player 2. So it's just like to test that everything works properly, whatever player is playing. We're going to copy that again. So now this, you can see that this test is going to be exactly the same like this one, but now this test is going to be, this transaction is going to be sent by player 2. So it should still go through because we had 2 tickets, so we still have tickets available. And now let's check that we don't have any. So now the new state of the contract at this point should be that there's no more tickets available because we set it to 2 tickets available, and we have 2 players that played, and we should also have 2 players in the players map. So that's what we're going to evaluate now. So we're going. Don't forget to get the storage again, because if you use the storage here, then it's the old storage before the transactions, and you're not going to get the results that you were expecting. So here we get the fresh storage, and then we can start. So because this one can look a little bit strange to do that, but remember that when you use assert is going to return a unit, and if I just actually I can show you, like what's going to happen. So here the storage tickets available should be equal to 0n. Okay, let's put that here. Now you will see that the compiler is going to complain about it. Okay. So what's happening is that here assert every function returns something, even if it's a unit, even if it's a value of type unit, every function returns something. And here, what happens is that this one is going to return unit, and then here we have another, and here we return unit again. So the compiler is a bit confused about that. That's why you have to write it like that. So here it means, okay, I know you return something, but I don't care about that value. I just want to evaluate. Evaluate this assertion, and then here you can return the unit. And put in. Let's see if it's correct. Okay, and now let's write this one, assert, and we're going to assert that the players map. So here we can use the map module here to get the size of this map. And yeah, actually I will also have to do that. Actually, probably not. And then here the size should be equal to 2n. Everything works here. So here everything is good. So we have 2 players that are playing, and they bought 2 tickets. We had a maximum a maximum of 2 tickets in the contract, and now we have we had 2 tickets available in the contract, and now we have 0 tickets available in the contract, and we have 2 players playing. So now we can check again that if we try to buy another ticket, that's not going to work. So you remember here we check that if there are zero tickets available, then it's not possible to buy a ticket. So we can just copy this test here. So now buy tickets, 1 Tez. We don't really need to change the source of the transaction because it doesn't matter who sends a transaction. It's going to fail if there are no tickets. And here the message should be no tickets available. And actually this one I didn't need to copy it. I just need to copy the transaction to the contract. Okay, now you can see everything is okay. So here we tested that it's not possible to buy a ticket with 0 Tez. Then we tested that it's not possible it's possible to buy tickets twice. And then we tested that the storage has the expected state. And then when no more tickets are available, we tested that it's not possible to buy more tickets when there are no more tickets. So far so good. The contract behaves in the way we expected. Now we can test the end game entry point. For the end game entry point, if you remember from yesterday, so the end game the entry point is going to choose a winner, and then it's going to find the address in the map, and then it's going to send the balance of the contract to the winner. So here you already you can already understand that the balances of the players are going to change. One of the players is going to get an increase in his balance. So we're going to test that. So in order to test it, first we want to get the initial balance, so the balance that the players had before the transaction. For initial balance. And again, we use the test module where you have a get balance. So you see a lot of those methods in the test module. They're going to look like the methods that you would use in when you write the contract. So when you want to get the balance, for example, the balance of the contract, you have a get balance. Here we're going to use the test framework, the test module, to get the balance of the account. And then we just have to pass the address of player 1, and then we're going to do the same for player 2. So balance, test, balance of player 2. Okay, so here now we have the 2 balances of the players, and so we're going to send a transaction to the contract, so we can just reuse this one. No, just this one here. So now we're going to have here end game. So you remember the parameter here, buy ticket, end game. So now that's this entry point that we're going to test. So we test end game. You don't need to pass any. You don't need to pass an amount to the contract call here. So end game, okay. Normally it should go through now. Okay, we can. Well, let's just check that the transaction works. Okay, so yeah, of course I'm not using those ones yet. Make it like that. Let's see if we can end the game. Okay, we can end the game. And okay, now we can check the balances. So for this test, like we can, so we don't know which player won. We would have to maybe to put something in the contract to track the last winner, so we can check the balance. Here we're just going to write a very general test to see if one of the two players had an increase in their balance. So we're going to get the new balance first. So I'm just going to do the same here, but I'm going to call it new balance. And now let's write the test. Okay. So assert. One of the two players must have an increase in their balance. So we're going to assert that the balance of the new balance of the player one is greater than the initial balance of player one, or the new balance of the player two is greater than this one. So one of these two is going to evaluate to true, and then the other one is going to be false. But because it's or, then it's going to be true. And then if they both evaluate to false, that means there's a problem and the test is not going to go through. Okay. Okay, so you see here the test works properly. So it's maybe it's not something that you want to do for a bigger and more complex contract. You would like to track, who won the last round, and then you can make sure that because here we don't know which one has a greater balance, and maybe something happened in the background, or some unexpected increase in balance or something. So not for this contract because it's very simple, but if you work on a more complex contract, then you would like to write something a little bit sturdier than that. But here for the purpose of this demonstration, it's going to be enough. And we can see that one of the two players had an increase in balance, which means that someone received some Tez, and we didn't send any Tez, just the contract sent some Tez. So we can assume that the Tez come from winning the game. And now what we would like to do, so you remember here at the end of the game, where is it, end game, here we reset the storage of the contract. So we in order to prepare the contract for a new round and new players who can play. So the players map is going to be empty, and then the number of tickets available is going to be equal to the number of max tickets. So you remember a little bit before here we tested, what was that? We tested, here we tested that there's 0 tickets, okay, available. So now we should have 2 tickets available. So we're going to test that. So actually we don't really need to reinvent the wheel. We can just copy paste it like that. So we get the storage again. So we get the new state of the storage. Here we're going, and just a little note. You see that I'm using that name storage every time. And you probably know that in Camel LIGO the variables are immutable. What I'm doing here is called variable shadowing. So you can reuse the same name, and as long as you use let in front of it, then the compiler is going to understand that it's a brand new variable. Actually, I'm not. Here it looks like I'm changing the value of storage, but I'm not. I'm just reusing the name storage, and every time I'm using it, it's a brand new value that has no connection with the value that storage had before. So this specificity of LIGO allows you to reuse the same names. So you don't have, for example, if you were writing that in JavaScript, you would have to write something like storage 1 and then storage 2, storage 3. You would have to come up with a different name for the storages, just to make sure that the new value of the storage doesn't overwrite the previous one. Here in Camel LIGO, it's very simple. You can reuse that the same name for the variable, and you can be sure that it's going to be a brand new value that has no connection with the previous storage. So that's why I'm reusing it. and it's also a little bit easier to reason about your code. Like I know it's the storage because I call it storage all the time. So here now we have to check that tickets available are 2 and that the size of the map is 0. And hopefully that works. Okay, and it works. So as you can see, we send the transaction here. We had a winner, and then when we check the storage, we can see that the storage has been reset to its previous state. So it's the state that we actually set here and that we tested here. So the contract behaves in the expected way. And just to finish, I'm going to you remember the end game? There was a fail with here. So if there are still tickets available, you are not able to end the game. So so you want to make sure that someone doesn't come and call the end game entry point and ends the game when the game is still not finished. So here we're going to test that, and we once again are going to reuse this contract call here, and so we're going to use to call endgame 0 test, and here also because I reuse this one because we want to check the error message. The error message that we expect is this one: game is yet to end, like that. So here we have the contract call with the transfer to contract, with the contract type, the entry point, the value, the test that you send with the transaction, which is 0. If it works, so it's not supposed to work. So that's why we assert false. So we can have an error message if the transaction went through. And then here we're going to test that the message that we get is game is yet to end. Okay. And that's it. You see everything. So you have this message. There's no. I can show you that it works. If you remove. The thing about the test in Camel LIGO is that sometimes it's so fast that you have that feeling that maybe it didn't work, or so you can check like that, and you will see that it does work. You see that I just removed the E here, and then it fails. Yeah, you see here fail with failed assertion. It's this one. So you see that it indeed it worked. And then I put it back and I run the test again. Then everything worked. So now we can be sure that the contract behaves in the way that we expect and that we implemented, and we wrote all those tests using the same language as the contract. So you don't have to use another language like JavaScript to write your test. As you can see, when I compile the test and I run them, so yeah, when I do that, the compiler is actually going to compile the test and then run them, and you can see that it's really fast. Like it takes like a second. So writing tests in LIGO is really fast. It's very once you understand the syntax and you're comfortable with it, it becomes very intuitive to write the tests, and you can reuse a lot of things that you know from the contract. There are a few things that you need to learn to run the test. But it's not very complicated. The test module has a lot of methods you can use, and then you can write your test. You can make sure the contract is correct. For example, if I have a test here that doesn't work, not because of the test, but because there's a problem with the contract, I can just switch the tab. I go here, I correct my contract. I come back here, I run the test again, and then the new contract, the new version of the contract is going to be here, so you don't have to use your JavaScript framework and then change the file and correct your file and have a new file or something. It's already included automatically. You run your test, and you can make sure that your contract is safe and everything works properly. So that was it for the presentation of the test. I don't know. if there are any questions about it.
No, so there are no questions from the audience. Yeah, so I would like to thank Mr. Crowd for actually presenting on smart contracts in LIGO, and thank you so much for all your time you have spent to actually teach the TezAsia Hackathon participants in this hackathon. So yeah, have a good day, and I
Thank
see
you
you
very
soon.
much. Thank you.
Thank
See you soon. Have a good
Yeah,
day. Bye.
bye.